Good morning, students. I hope you have completed your revision portion as we have been discussing revision in your live classes about the graph, linear equation solution and all. So you have to practice those questions in case for your half-yearly assessment. Right? Now today we are starting with one of the topics, probability. Probability, very simple topic but in itself a very huge topic. Probability. What does the word probability mean? Probability we use in our daily life. Probability means number of chances. Right? And number of chances can be anywhere, taken anywhere. We are assuming, right now we are assuming that the school reopens in 15th of October, from 15th of October or from 1st of November. That is a chance. We are assuming something. We are assuming that it will be raining outside. That is again a chance. Possibility. Yes, when we see IPL is going on right now, when we see a coin is being tossed, right? How many results are there on the coin? Two results, either head or tail. But when a coin is tossed, a captain calls it say head. He is taking a chance, right? That is called probability. We do not know what is the final outcome. We are taking a chance. For example, when we talk about multiple choice questions, how many results are given to you over there? 4 options. Option A, B, C and D. You do not know what option is the correct. You did A. You took a chance. After out of 4, only one result is possible. That is a chance. That is what we mean by probability. Taking a chance. We say no, we bet. Betting goes on. When we talk about IPL, betting goes on. Team Mumbai Indian and Rajasthan Royals, who's going to bet in Mumbai is going to win. That is again a chance. We do not know. Right? That is what you mean by probability. And all the examples I gave you are called as events. Tossing of a coin is an event. Selection of a team, which team is going to win, Mumbai or Rajasthan, is an event. Betting that it is going to rain outside, event. Tossing, throwing of a dice, all of us know when we play Ludo, there is a die, singular die. When we throw it, how many results are there? 6 results are there. But when it is rolling, do we know which result is going to appear? No, it can be 1, 2, 3, 4. That is a chance. Probability. Right? When a batsman is hitting a ball, there is a quite a bit of chance that it goes for 6, it goes for 4 or it does not go anywhere. That is what? Probability. In our daily household activities, we use probability every day at our homes also. When we talk, what is the mother cooking today in the food? We are assuming, we are taking a chance, she'll cook dal. That is probability. We don't know what is being cooked, but we are assuming that it is this is what going to be. That is probability. When we go to the market to purchase anything, we assume that it is going to be 20 rupees, but it is 30 rupees or 40 rupees. We are taking a chance. That is what we mean by probability. And all these are examples. When we select a student from the class randomly, out of 40 students in a class, supposedly 2 students are selected, have to be selected, or 1 student has to be selected. The teacher comes and says, roll number 35. That is what? Probability. You were assuming there were 40 students sitting in the class. Out of those 40, student teacher has to select 1. She picks up roll number 45 or 35. That is probability. Yes. This is what we mean by probability. Taking a chance. We do not know. I give you a box full of chocolates and it is a mixture. Some are eclairs, some are mango bite. I tell you to pick one chocolate, one toffee out of that. You cannot see which chocolates are there. It is all covered up. I tell you to pick one. Can you pick a mango bite? Yes. Can you pick an eclairs? Yes. That is probability, nothing else. What does probability mean? Probability means possibility, taking a chance. very simple formula is there for probability. When we talk about probability, very simple exercise. You have done it in class 8, you will do it in class 9, and you will again do it in class 10. This chapter is again there in class 10. Whatever we are discussing today will again be repeated in class 10. It is no different. So what is probability? Probability of an event. I gave you certain examples of an event. Tossing of a coin, throwing of a dice, selecting of a student, selecting a team. That is probability. When we go to a party, we select a dress. Out of 10 dresses available, we select one. That is probability. Your mother is assuming, no, you will wear this dress, but you pick something else. That is probability. So what is probability of an event is equals to number of favorable outcomes. Favorable outcomes means results which are in our favor upon total number of outcomes. The best example or to understand probability nowadays is a coin. Let me see if I have a coin in my pocket. Yes, I have a coin. Right? I have this coin, 2 rupee coin with me. On this you have the emblem and here you have the amount written 2 rupee. Now this is head and this is tail. When I am tossing this coin, how many results are possible? 2 results are possible. Either it can be head or it can be tail. 2 results are possible. But out of those 2 results, if I have gone for head, which is my favorable outcome? Head. That is how many? 1. Out of how many? 2. Out of 2 results, 1 result is in my favor. So what is the probability of getting head? 1 by 2. Yes, the other person who I have got head. So what is the favorable result for him? 10. That also is 1. 1 favorable result out of how many? So that is what we mean by probability. Clear? Now, here are few things. Tossing of a coin, for example, this is an event, tossing of a coin. Number of possible results, 2 results are possible. Either it will be head or it will be tail. Isn't it? Yes. Throwing a dice is a result, throwing a die. How many results? Total possible results are 6. And which are those results? It can be 1, 2, 3, 4, 5 or 6. When the dice is rolling, we do not know which result is going to come. Cards, playing cards. Is it? Playing cards. You must have seen. There are 52 different cards. All those 52 different cards are having some or the other difference. And you will be shocked to know this probability started from the game of cards. There was a gambler who went to a mathematician to find how many chances he had of winning. And from there, this probability started. From there, the mathematician started working or thinking about probability. Alright? So you can see the theory. It is there in your textbook. So we will not discuss about that. So what is the probability of an event? Any event. Number of favorable outcomes upon total number of outcomes. And probability of an event is always greater than or equals to 0. But less than equals to 1. It cannot be less than 0, it cannot be greater than 1. How, sir? Just imagine, I will come back to that point. I have this coin, I toss it, how many results possible? Sir, 2 results possible. Out of those 2 results, I say, if head comes, I win, tail comes, you lose. Look at the words. Head, I win, tail, you lose. If head comes on the coin, I will win. But if tail comes on the coin, you will lose. So what is the probability of me losing? I will never lose. So both the results, whether the head comes or sorry, my coin fell down. I am tossing a coin, right? Either it will be head or tail. Can any other result be possible? I am tossing a coin and I say that the coin will disappear. Possible? No, sir. Or I toss a coin and I say the coin will be held like this. Only in movies it is possible, not in real life. Isn't it? So what is the probability? It can never be equals to, it can be equals to 0, but it never be less than 0. And probability of an event plus probability of not an event is always equals to 1. What do I mean? Say probability of getting head 1 by 2. One time only head can come, out of how many? 2. And probability of not getting head means what? Coming tail. So probability of getting tail again 1 by 2. So 1 by 2 plus 1 by 2 is equals to what? Here. So this is what we mean by probability. And sample space. What is sample space? All the possible results in an event is called a sample space. When we talk about possible outcomes in a coin, how many sample space? 2. Head or head and tail. When we talk about a die, how many sample spaces? 6 sample spaces. Which are they? 1, 2, 3, 4, 5 and 6. This is what we mean by sample space. Clear? Now, very simple questions are there in your textbook which we can very easily understand and very easily we can solve. For example, our first question, page number 283. Page number 283, 15.1 and first question. In a cricket match, a batswoman hits a boundary 6 times out of 30 balls she plays. The best IPL is going on. How many balls were played? Total number of balls played. Total number of balls played is equals to 30. Number of balls hit for boundary. Number of balls hit for boundary is equals to 4. Sorry, 6. Yes, 6. Right? So our question says, forget it, total number of balls was played by 30 and number of balls hit for a boundary were 6. So how many balls were not hit for the boundary? Sir, 30 minus 6, 24. Isn't it? Question says, find the probability that she did not hit a boundary. So therefore, number of balls did not hit for boundary, did not hit for boundary is equal to total 30 minus 6, how many? 24 balls were not hit for the boundary. And what is the event? So therefore, probability of an event. What is the event? They did not hit for a boundary. Read it. He says, find the probability that she did not hit a boundary. Probability did not hit a boundary is equals to number of times did not hit a boundary. Number of times did not hit upon total number of balls. Total number of balls played. So how many balls you did not hit a boundary? 24. And what is the total number of balls you played? 30. So 24 out of 30, I can see 6 4s are 24, 6 5s are 30. So 4 by 5. What is the probability? 4 by 5. Don't convert it into decimal. Leave it into fraction form. And you can see 4 by 5. Is it greater than 0? Definitely, sir. Is it less than 1? Yes, sir, because it is a proper fraction. All of us know what is proper fraction. When denominator is greater, numerator is smaller. That is a proper fraction and it will always be less than 1. In the same, if I ask you, probability of hitting a boundary. Probability of hitting a boundary. Hitting a boundary. So that is equals to number of balls hit for boundary. Hit for boundary upon total number of balls. Total number of balls. So how many balls are hit for boundary? 6. Out of how many? 30. So 6 1 is 6, 6 5 is 30. 1 by. This is probability, nothing else. No need to convert it into decimal or something like that. Take a look at second question. 1500 families with 2 children were selected. All of you are living in families. Yes, you have father, mother, and you might have a brother or a sister, elder or younger. Maybe both of you are girls. Yes, 2 children are there. Maybe both of you are girls. Maybe both of you are boys. Maybe one boy and one girl. Possible? So he says 1500 families with 2 children were selected, and the following data were recorded. See, number of girls in a family 2, 1 and 0. How many number of families? 475 families were there who were having 2 girls. That means both their children were girls. One girl. 814 families were such which were having one girl. And the other one? Boy. 0 girls. 211 families. Both of them had 2 boys. That means 0 girls. Question says, compute the probability chosen at random being 2 girls. So second question, if I talk about first part, probability of having 2 girls. 2 girls is equals to number of families with 2 girls upon total number of families. Total number of families. So you can see the table. How many families are having 2 girls? Only 475. And what was the total number of families? 1500. Simple. Can be simplified. You can reduce it by 25. You can reduce it by 5 as you like. Say 5 9s are 45. Carry 2. 5 5s are 25. 5 3s are 15 and double 0. Again by 5. 5 1s are 5. Carry 4. 5 9s are 45. 5 6 are 30 and 0. So 19 upon 6. Yes. Second question, probability that it is a 1 girl. Second, probability of 1 girl is equal to number of families with 1 girl upon total number of families. Total number of families. So number of girls with one girl. How many? 814. You can see the table. Out of how many? 1500. Can we simplify? Isn't it? Simplify, cancel. 2 2s are 4. 0. 2 7s are 14. 2 5 2 7s are 14. Carry 1 2 5s are 10 and 0. 207 upon 7. Simple questions, nothing much. Then he says no girl. Third part. Probability of no girl. That means both of them are boys. So number of families with 0 girls or no girl upon total number of families. Total number of families. So number of girls. How many families? 211 out of 1500. It cannot be reduced, so leave it as it is. That is what we mean by probability. Nothing new, nothing different. All the questions are very, very simple. Clear? Only thing you have to remember, only one formula. Probability of an event is equal to number of favorable outcomes upon total number of outcomes. That's clear. Let us see a few more questions, then we shall discuss. Say, for example, he says, fourth question, 3 coins were tossed simultaneously. How many coins? 3 coins. Right? And when 3 coins are tossed, how many results are possible How many results are possible? Various number of results are possible. Various number of results. See, if 3 coins are there, it is possible that all 3 coins have head. First coin also had, second coin also had, third coin also had. All 3 coins have the same result, that is 3 heads. Then he says it is quite possible that the 2 coins are showing head. One coin is showing tail. 2 head, 1 tail. It is possible that it is 2 tails, 1 head. And it is also possible that all the 3 have tails. Yes, the question says just take 3 heads 23 times, 2 heads 72 times, 1 head 77 times, and no head 28 times. How many times the coins were tossed? 200 times. Total number of times the coin was tossed was 200. Question says if 3 coins are tossed simultaneously again, compute the probability of 2 heads coming up. Number of times 2 head comes is equals to how many times 2 head is coming? 72 times. And what is the total number of times coins are tossed? Total number of times coins are tossed is equals to 200. So therefore, probability of 2 head is equals to 72 out of how many? 200. Simple question. Yes. 2 3s are 6, 2 6s are 12, 2 hundreds are 2 1s are 2, 2 8s are 16, 2 50s are 2 9s are 18, 2 25s are 50. So it is 9 by 25. If I further ask the question and ask the probability of no head, that means all were tails, all 3 results were tails. So how many times 0 head or no head? 28 out of 200. What was the total number of times coins were tossed? 200 times. So 2 1s are 2, 2 4s are 8, 2 hundreds are 2 7s are 14, 2 50s are, so that is 7 upon 50. Clear? So you can see these are not difficult questions. You can do these questions. There are no tough questions over there. Some of the questions he is telling you to use the table of the previous chapter. Which table? For example, if I talk about question number 6, refer to table 14.7, chapter number 14. Table 14.7, chapter number 14. So let us go through the previous chapter and see table 14.7. Where is table 14.7? Table 14.7, if I see, is on page 251. Page 251. Can you see this? Page 251. Table 14.7 on page number 251. Question number 6. If I look at this table, I will see that it is the table is about marks 0 to 20, 20 to 30, 30 to 40, 40 to 50 and so on. And number of students, how many students got how many marks? 0 to 20, how many students? 7. 20 to 30, 10. 30 to 40, 10. 40 to 50, 20. 50 to 60, 20. 60 to 70, 15. 70 and above, 8. 70 and above, 70 to 80, 80 to 90, 90 to 100, how many? 8. And total number of students given to us is what? 90. So what is the total number of students in this question? According to table, total number of students is equals to 90. As in class 9 right now. There are around 30-35 students, so 3 sections together brings out to be 90. Yes. Now he says, first part, find the probability that the student obtained less than 20% marks in mathematics test. First one, probability of student less than 20% is equals to number of students less than 20% upon total number of students. Total number of students. So you can very well see what is the total number of students. 90 it is already given. And let us go to the table. Let us go to the table and we see less than 20. How many students? Between 0 to 20, how many students? Only 7. They are less than 20. So that is 7 upon 90. Simple. Second part, it says a probability of a student obtained 60% or more. Second, probability of a student more than 60% is equals to number of students more than 60% upon total number of students. Total number of students. So we can see total number of students remain the same, 90. From 90, how many students are there who are getting more than 60? So let us look at the table. More than 60, 60 to 70, 15 people, and 70 and about 8 people. Are they also more than 60? Definitely, sir. A person getting 74 marks, is he getting more than 60? Yes. Is he getting more than 70? Yes. He is appearing in both of them. So more than 60, 60 to 70 there were 15, and 70 to 80, more than 70 were 8. So 15 plus 8. 15 plus 8, 23 out of 90. Clear? So this is the questions of the probability. You can see, and if you have any doubt in any of the questions, kindly WhatsApp to me or contact me. You will be able, your problem will be solved. Any other kind of question? Right now in class 9, we are going to discuss only simple probability. In class 10, when we come down, you will have probability of cards, probability of coins, probability of dice, and everything. Clear? Here we are going to discuss about only probability of selection from a certain group of numbers or a certain group of people. Clear, students? So kindly practice it. Any doubts you can ask. We can solve the rest of the questions also if you wish to. But they are not difficult questions. Please try and practice. Okay? Thank you.